Welcome to Quick MCAT Lessons, where I try to explain MCAT topics in 10 minutes or less. Today, I'm going to dive into how the kidneys regulate blood pressure, pH, and hormones. 3 critical roles that show just how powerful and precise renal physiology is. First up, blood pressure. So the kidneys play a huge role in long-term blood pressure regulation with a few major mechanisms. The key player here is the renin-angiotensin-aldosterone system. Now we've talked about this before, but I just want to do a quick overview and really highlight the kidney's role here. So we've talked about this before, so I won't go into a lot of detail, but I will give a good overview so you can understand the role of the kidney. So when blood pressure drops, either due to low blood volume, low sodium, or sympathetic stimulation, the juxtaglomerular cells in the afferent arteriole release renin. Renin converts angiotensinogen made by the liver to angiotensin 1. Angiotensin 1 gets converted to angiotensin 2 by ACE, which is found in the lungs. Angiotensin 2 leads to an increased aldosterone release. Aldosterone works on the distal convoluted tubule and the collecting duct to reabsorb sodium. Now it does this because if you reabsorb sodium, you get a concentration gradient, then water will also flow in. You'll get a higher blood volume and you'll get a systemic blood pressure increase. Also, if your blood osmolarity is increased, which it will be due to high sodium, you will get an increase in ADH. ADH is antidiuretic hormone. This will also retain water. This will also lead to increased blood volume, which will also lead to increased blood pressure. Furthermore, if you have a decreased urine osmolarity in the distal convoluted tubule, this will get detected by the macula densa. The macula densa will lead to the dilation of the afferent arteriole, and this will increase blood flow and blood pressure in the glomerulus. And so the increased blood flow and blood pressure in glomerulus, combined with the systemic blood pressure increase, both lead to increased glomerular filtration rate. And the glomerular filtration rate, or the GFR, is a key measure of kidney function, specifically estimating how well the kidneys filter waste and excess fluid from the blood. If the GFR is too high, the kidneys can undergo damage. And so to avoid damage, kidneys can tightly regulate blood pressure by controlling this RAS system as renin is released from kidneys. Next, let's talk about pH regulation. The kidneys maintain acid-base balance by controlling bicarbonate and hydrogen ion levels in the blood. And we also talked about this in the bicarbonate buffer section that you can watch again. So recall that carbon dioxide and water, with the help of carbon anhydrase, form carbonic acid, which quickly dissociates into bicarbonate and protons. Now, too much bicarbonate will lead to a high pH, and too many protons or hydrogen ions will lead to a low pH. And so it's very simple. If the plasma pH is too high, then bicarbonate is excreted in the urine, and when the plasma pH is too low, hydrogen ions are excreted. Also, carbonic anhydrase, which is the enzyme that converts carbon dioxide into carbonic acid, is found in epithelial cells throughout the nephron. This allows the reaction to take place right there, and then the kidney can adjust the pH by excreting bicarbonate or protons as needed, adjusting the pH to ideal levels. Now also recall that renal pH adjustments are slow. They may require several days to return plasma pH to normal after a disturbance. The other organ important for pH regulation is the lung. It does this by controlling inhalation and exhalation. So by exhaling excess CO2, the lung removes the carbonic acid from the blood, raising the pH. This is how hyperventilation works, which is deep, rapid breathing. Because you're removing CO2, thus you're removing carbonic acid and you're raising pH. And this takes effect in just minutes. Finally, let's move on to the endocrine role of the kidney. So several hormones affect the kidney, but the kidney makes one as well. And all of these are peptides except aldosterone, which is a steroid. So the one that the kidney makes is called erythropoietin, or EPO. EPO causes increased synthesis of red blood cells in the bone marrow, and it's released when blood oxygen content falls. Now you may have heard of some athletes taking EPO, and they do this because it increases red blood cell production and oxygen supply to muscles is enhanced. This increases stamina, helping them perform better. Next, let's start with the aldosterone. The source of this is the adrenal cortex. It causes sodium reabsorption and potassium secretion by increasing the synthesis of basolateral sodium potassium ATPases in the distal nephron. End result is there's an increased serum sodium and increased blood volume through the action of ADH, and all of this leads to increased blood pressure. Next, we have ADH. This is from the posterior pituitary, and ADH is secreted when plasma volume is too low, blood pressure is too low, or plasma osmolarity is too high. This causes water reabsorption by causing epithelial cells of the distal nephron to become permeable to water, which allows water to flow out of the filtrate into the medullary interstitium. The vasa recta returns this water to the bloodstream, and the result is more concentrated urine and more diluted blood. ADH and aldosterone work together to increase blood pressure. First, aldosterone causes sodium reabsorption, which results in increased plasma osmolarity, which causes ADH to be secreted, which results in increased water reabsorption and thus increased plasma volume. Now we have calcitonin. This is secreted from C cells. C cells are located in the thyroid gland, but they do not secrete thyroid hormone. They secrete calcitonin, and they do this when the serum calcium concentration is too high. Calcitonin causes calcium to be removed from the blood by 1. Deposition in bone, 2. Reduced absorption by the gut, and 3. Excretion in urine. Finally, we have parathyroid hormone, which is secreted from the parathyroid. There are 4 parathyroid glands found embedded in the thyroid. The function of parathyroid hormone, which is also called parathormone or PTH, is opposite that of calcitonin, and so it essentially increases calcium concentration. And it does so by the same ways calcitonin works. So it increases absorption in the gut, it decreases excretion in the urine, and it breaks bone to get the calcium from there. And that's it for today. I know a lot of this was review, but I hope it helped tie everything together. Next time we'll actually go over some practice questions.